welcome to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze a gate valve for its modal analysis. We will start by double-clicking on the modal module. Next, we will go to engineering data and double-click. Engineering data sources, general materials. I will choose one of the material as stainless steel. Then I'll click on engineering data sources again and I will add two more materials. One is brass, for which we have to give the value of density 8490 kg per meter cube. Click on brass once again and double click on isotropic elasticity. We have to give the value of Young's modulus. It is 97 gigapascal. So I just change this to gigapascal and here I'll give the value as 97. Value of Poisson's ratio is 0.31. The next material which I'm going to add is bronze. I'll go to density and double click. I'll give this value as 8410 kg per meter cube. Click on bronze once again such that these options open up. Click on isotropic elasticity. You have to double click. Value of Young's modulus is 138 gigapascal. So I'll change this to gigapascal. 138. Value of Poisson's ratio is 0.42. Then I'll go to project and update project. Next I'll go to geometry and I'm going to right click and import the geometry because I already have the model made with me. Next I'll go to model and double click. First I'll go to geometry and click on this plus sign. Now I have to change the material. So first I'll change the material for each of these. I'll just click on the shift button and select all of them. Here I'll change the material to stainless steel. Next I'll go to mesh and update the default size of the mesh. Then I'll go to model A5. I'll right click here and insert fixed support on both the sides. So I'll select here and also this one, apply. Next I'll go to solution A6, right click here and just click on solve. So once you get the solution, you can see here there are 6 modes and 6 frequencies obtained. Then we'll click here, right click, select all, right click, create mode shape results. So now when you see here, all the 6 deformations can be seen. We'll click on solution A6 and solve. So once you get all the solution, you can go to the total deformation 1. You can animate and see the pattern of its deformation. The maximum deformation value is 128.38 mm for a frequency of 1361 Hz. The next one has total deformation of 125.1 mm. At this end, you can see here. You can animate and see its pattern. The frequency is 1411.5 Hz. The next one is deformation 3. Total deformation maximum is 133 mm and frequency is 1632.6 Hz. Then we'll go for total deformation 4. You can see the pattern of its motion. Value of deformation is 161.61 mm for a frequency of 2537.8 Hz. Deformation 5, maximum value is 151.89 mm for a frequency of 2615.2 Hz. Again, quite a high value. And the last one has more frequency than the fifth one, which is 3518.8 Hz. And the maximum deformation is 147.6 mm. You can also see the pattern of this motion. So this shows you clearly how the body is going to vibrate under these frequencies. Now we will go to material, click on this, we'll go to geometry and click on this plus sign and change all these material to brass, and let's see the result. So we can solve once again. It hardly takes few seconds to solve, it's not a big solution. So it just takes few seconds and the solution is done. So we'll go for the first deformation. Again, the pattern for the three materials that we have used is going to be the same. So you may or may not check the animation again and again. It is going to remain the same. But you may still, because it happens that sometimes because of a very low frequency or for a high frequency, the pattern changes. It's very rare, but you can check still. Value of deformation is 122.66 mm. For second one, the value of deformation is 119.52 mm. You can see the deformation have reduced. And the frequency is also 956.04 Hz. So the natural frequency has lowered and so has the value of deformation. The lower value does not mean that it is safe. It is possible that lower values are easily attainable at times. So lower value does not guarantee that you should go for this material. It is just that modal analysis always tells you what are the frequencies which you should not tap such that the body does not go into resonance form. Now for the third one, the value of deformation is 127.07 mm maximum and the frequency is 1105.8 Hz. In the fourth case, maximum deformation is 154.41 mm for a frequency of 1719 Hz. See the animation. Then for the fifth one, maximum deformation is 145.12 mm for a frequency of 1771.4 Hz. And in the sixth case, value of deformation maximum is 141.02 mm for a frequency of 2383.4 Hz. Now last, let's change the material for each of these parts to bronze and let's see what happens. We go to solution again and solve. Let's see the total deformation. Value is 122.2 mm maximum for a frequency of 1134.6 Hz. Second deformation maximum is 119.52 mm for 1172.5 Hz. The third deformation maximum is 128.15 mm for frequency of 1310.9 Hz. Then we'll go for the fourth one. Maximum deformation is 156.15 mm for frequency of 2094.5 Hz. You can see the pattern of its motion. Then we'll go for the fifth one. Maximum deformation is 149.28 mm for a frequency of 2137.6 Hz. And the last one is 141.44 mm for a frequency of 2893.7 Hz. The pattern as we observed of motion was same for all the three materials for a particular deformation value. So with this I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.